Okay, in today's lecture, we'll start with the continuation part of your third module, that is modulus of subgrade reaction of soil plate bearing test. So, in previous, we have studied about the bearing plate test, isn't it? So, this is plate bearing test was originally meant to find the modulus of subgrade reaction in the Westergaard's analysis for wheel load stresses in cement concrete pavement. In the plate bearing test, a compressive stress is applied to the soil or a pavement layer through rigid plates of relatively large size, and the deflections are measured for various stress values. The deflection level is generally limited to low value, that is 1.25 mm to 5 mm. The modulus subgrade reaction K may be defined as the pressure sustained per unit deformation of the subgrade at specified pressure level using specified plate size. The standard plate size of finding K value is 75 cm diameter. In same test, a smaller plate of 30 cm dia is also used, that is 75, 60, 45, 30, 22.5 cm dias. The procedure is as follows. At the site, about 20 cm of topsoil is removed and the site is leveled. The plate is properly seated on the prepared surfaces. Means at the site, 20 meter of thickness of this top layer of the soil has to be removed. The site is leveled and plate is properly seated on the prepared surface. The stiffening plates of decreasing dia are placed and the jack and proving ring assembly are fitted to provide a reaction against the frame. Means these plates are to be arranged to the surface in a decreasing order of the dia. Then this dial gauge has to be attached, dial gauge and the jack and the proving ring has to be attached. 3 or 4 dial gauges are fixed on the periphery of the plate from the independent datum frame for measurement of the settlement. Means 3 or 4 different dial gauge has to be attached at the periphery of the plates. A seating load of 0.07 kg per centimeter square, that is 320 kg for 75 dia, is applied and released after few seconds. Means the load is going to be applied then released. The settlement dial gauges readings are now noted corresponding to 0 loads. Now, whatever the settlement is going to happen, that is going to record for the 0 loads. A load is applied by means of jack sufficient to cause an average settlement of about 0.25 mm. When there is no perception increase in the settlement, or when the rate of settlement is less than 0.025 mm per minute, the cases of clay soil and wet soil, the reading of settlement dial gauge are noted and the average settlement is found and the load is noted from the proving ring dial reading. The load is then increased till settlement increases to the further amount of about 0.25 mm and the average settlement and the load are found. The correction for smaller plate size. In some cases, loading capacity may not be adequate to cause 75 cm of the diameter of the plate to settle 0.175 centimeters. In such cases, a plate of smaller dia, say around 30 cm, may be used. Then the K value should be found by applying a suitable correction for plate size. Assuming the subgrade to be an elastic medium with modulus of elasticity E, The theoretical relations of deformation, that is under a rigid plate of radius in centimeter, is given by the delta equal to 1.18 Pa divided by E. 1.18 Pa divided by E. But K equal to P by D. Substitute the values of D and K. Therefore, K equal to P into E divided by 1.18 times E. The value of E is taken as a constant for a soil, then K into A is equal to a constant. Hence the test is carried out with a smaller plate of radius A, and the modulus of subgrade reaction K is found as K equal to K1 A1 divided by A. So this is what the constant. Again, there are various different materials are there, as we know. We have studied about the subgrade soil now so far. So we'll go to the aggregates. So aggregates also one of the important elements or components in the road construction. Aggregate form a major portion of the pavement structure, and they form a prime materials used in the pavement construction. So aggregate have to bear stresses occurring due to the wheel loads on the pavement on the surface courses. They also have a resist wear due to abrasion action of the traffic to the wheel loads on the pavement, and on the surface courses they also have to resist wear due to abrasion action of the traffic. Okay, so this is the one of the important material in the road pavement construction is, and in the road it is the the part which we are going to use for the construction of the pavement. Okay, so here the aggregate has to bear stresses. Aggregate has to bear what? Stresses occurring due to the wheel loads. Whenever the vehicles are going to be on the road, there will be loads which are going to be transferred through the wheels, isn't it? So there is a abrasion action is going to be taken place. Abrasion action is going to be taken place. This is to the what? Aggregates. Okay, so abrasion test has to be carried out for the to check the quality of the aggregates, and aggregates are has to have a resist wear due to abrasion action of the traffic. Then properties of aggregates. Again, in the properties of aggregates, it is the strength and the toughness, durability, strength, toughness, durability, shape of aggregate, and adhesion with the bitumen. These are what are the 5 different properties of the aggregates here. One is the strength. The aggregates to be used in road construction should be sufficiently strong to withstand the stresses due to traffic wheel load. The aggregates which are going to use for the construction of roads should be sufficiently strong. What should be sufficiently strong enough to withstand the stresses due to traffic load. Okay, and the aggregates which are to be used in the top layers of pavements, and particularly in wearing courses, have to be capable of addition to wear and tear, hence they should possess sufficient strength resistance to the crushing. These whatever the aggregates we are using, they must have the sufficient to carry the loads and to carry the wear and tear of the action. And the toughness. Aggregate in pavements are also subjected to impact due to the moving wheel loads. Severe impact like hammering is quite more on the water-borne macadam roads, WBM roads. There is a huge hammering action is going to happen. Where stones protrude out, especially after the monsoon. And after monsoon, the whatever the aggregates, they are going to become on the top. Okay, because the whatever the water the soil is going to be eroded due to the rains. Due to the rainwater, soil is going to be eroded. The aggregates are going to protrude from the pavement. Okay, so in such cases they are very vulnerable to the impact loads of the wheels of the vehicles. The durability. The stone used in pavement construction should be durable and should resist the disintegration due to action of weather, The property of stones to withstand the adverse action of weather may be called as soundness test. Okay. Then the shape of aggregate is also an important factor. The size of aggregates is first qualified by the size of the square sieve, opening through which an aggregate may pass, and not by the shape. Aggregates which happen to fall in particular size range may be rounded, cubical or angular, flaky or elongated shape of the particles. It is E and donated particles will have less strength and durability when compared with the cubical, angular or rounded particles of the same stone. Hence, too flaky and too much elongated aggregate should be avoided as far as possible. Size and shape of the aggregates plays a very important role in carrying the strength of the aggregate. Whatever the flakiness and angular type of flakiness, elongated, having the less strength when compared to the cubical or rounded particles. Cubical and rounded particles which are having the more strength as compared to this elongated and flaky type of particles. So these kind of particles has to be avoided. The shape which is to be there, cubical and rounded particles. The one more property is the adhesion with the bitumen. However, we are going to apply the bitumen for the roads. It should be strong enough to bond between the particles and other materials. So, adhesion with the bitumen. The aggregates used in bituminous pavement should have less affinity with water when compared with the bituminous material. Otherwise, bituminous coating on aggregate will be stripped off in presence of water. So whatever when you are going to aggregates used in bituminous pavement should have less affinity with water. Whatever the aggregates we are using, which should be less affinity with the water. What happens is, if any water accumulates on the surface of the aggregates, there will be a bonding will not be proper between the aggregates with the bitumen. So it should not be affinity with the water. So that care has to be taken. We'll stop here. We'll continue in the next class.